Huh. We have a graph of sine of x. Anybody know what that graph is? Cosine of x. That's tangent of x. Here's what I want you guys to understand, okay, is that these graphs of sine, cosine, and tangent have what we call even and odd properties about them. It was a long time ago, and I don't expect you to remember it all, just maybe if you remember that we somewhat talked about it. That's what I'm asking. Hopefully it's lodged there somewhere in your brain. Hopefully you haven't repressed it like geometry or other things in your life. So if I have this function, which is x squared, we say that that's an even function. We call it even because, number one, what do you notice about the exponent? Second of all, what do you notice? It's symmetrical about the y-axis, right? But by definition, here's what happens. F of negative x is the same as f of x. Or in other words, negative 3 squared, do you guys agree that that's the same thing as 3 squared? Yeah. In both situations, you get 9. One of these up here is even. Do you know which graph up here is even? The one that you can flip on the y-axis and it looks the same. Cosine of x. Cosine of x is even. So therefore, we learn that cosine of a negative angle is the same as cosine of a positive angle. And secant works out the same. Secant of a negative angle is the same as secant of that positive angle. They are both what we call even functions. We have what we call odd functions. Odd functions are like this. X cubed. X cubed is odd because if you turn it 180 degrees, you get the same shape. Also, f of negative x becomes negative f of x. Or in other words, is 2 cubed the same as negative 2 cubed? Are those the same? No, they're different, but just a little, right? This one is 8, this one's negative 8. So the negative moves to the outside. The other two functions are odd. Sine is odd and tangent is odd. What does that mean? If you have sine of a negative angle, you can simply move the negative out front. Now, the first time you see that, it might be confusing. You don't have to remember the y's. It helps to remember y, but maybe you would like to reference it and watch a video later on. We have negative tangent of theta right here. We have negative cotangent of theta right here. So these are what we call odd functions. Now, let me show you how you get to reference this and use this on the test. What we want to do today, and so I just taught you some new identities, we want to simplify trigonometric expressions. That's our goal for today. We start with simplifying sine times secant. One way in which we simplify trigonometric expressions is to rewrite everything in terms of sine and cosine. So I put together a second page that I feel is extremely helpful to you. While the first page I didn't feel you necessarily need to commit to memory, as many things on this page that you can commit to memory as you can is going to be beneficial to you. I cannot stress that enough. I was in a calculus class this year where somebody was asking me, well, why does it work out that way? And my response was, well, do you remember that secant is the same as 1 over cosine? And their response was, no, I don't remember that. And I said, well, I'm sorry, I cannot continue in my explanation then. Like, there's just certain things I'm if I'm going to conjugate hablar, I'm going to conjugate hablar. I should say hablamos, habla, hablan, hablas, right? Like there's certain things that you just want people in Spanish to know, right? I expect that everybody here is going to know that tangent is sine over cosine. Is that fair? Everybody's going to know cosecant is 1 over sine. Is that fair? Everybody needs to know secant is 1 over cosine. Everybody needs to know cotangent is cosine over sine, which is just the first one flipped, right? And everybody needs to know sine squared plus cosine squared is 1. This is fundamental. Just like the capital of the United States is Washington, D.C. You all know it. As soon as I say sine squared plus cosine squared is 1, you should know that. Okay? This is a great one to know as well, and we're going to reference all of these now within the next 20 minutes here. Are you ready to go? If you need to flip back, if you need to rip this off and look at it, it's up to you. Sam rips it off. Good. So somebody rip it off, and when you rip it off, accidentally hit the person next to you. You do it. It'll be really funny. Okay. All right. Okay, stop hitting each other. All right. Shout out to all those who participated in Optional Friday today. We are here. We're putting in blood, sweat, and tears. It's totally tough to put in a 3-day week, isn't it? Yeah. Dedicate this video to Mad Dog Mad. All right. Sine of theta times secant of theta. First goal, change it to sine and cosine. Sine of theta over 1 times. How do you rewrite secant? 1 over cosine. Hey, let's think about that. So sine over 1 times 1 over cosine is going to give you sine over cosine. What's sine over cosine? Tangent. I agree. Raise your hand if you agree with that statement. All right. Democracy. We win. Cotangent of theta times sine of theta. How do you rewrite cotangent? Cosine of theta over sine of theta. You know, people want to rewrite sine as 1 over cosecant. Don't. That doesn't help you. It's already written as sine or cosine. Leave it alone. As you leave it alone, what happens? Sines cancel, leaving you with cosine. For the record, Ashley just spoke forth. Ashley, what did you say?
I like this.
Thank you. Some people love simplifying trigonometric expressions. It's a good time. It's like a puzzle. One over cosine times 1 over sine, right? Does anything cancel? Well, I know that sine divided by cosine is something special. That's tangent. But is sine times cosine something special? No. In fact, this one does not simplify. Okay? So not very often, but every once in a while you do run across situations where it's like, well, that doesn't simplify. It's just good to go the way it is. Just secant theta times cosecant theta. Just leave it alone. I wouldn't give one like that to you. I just put that in there for effect right now so you guys could see. All right, cotangent times secant. Cosine of theta over sine of theta times 1 over cosine. What happens? Cosecant. I appreciate that you guys are using the full names of the trigonometric functions. Some people just say, oh, that's CSC. No, that's like a university that we're not aware of somewhere, okay? All right? That's like the College of South Carolina or something, okay? Cosecant, that's a trigonometric function, okay? We like that. All right. Tangent of theta. Times cancel Secant. 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 I'm trying. I'm pulling all the stops. Oh no, what's different about F? There's negatives. Oh. Well, we learned what to do with negatives. What happens in secant of a negative? It's just secant. Didn't we just make that list up top? Times what happens in cosecant of a negative? Negative cosecant of theta times negative cotangent of theta. Negative times a negative is a positive. Now we can just work it out. I got secant is 1 over cosine times 1 over sine times cosine over sine. One over sine squared, which is cosecant squared. Maya, you raise an excellent question, and I'm going to show you. No. Do you agree that that's the same as 1 over sine quantity squared? Agreed? What's 1 over sine? Cosecant. That's cosecant squared. So the first time I ever went through this process as well, I knew that everybody was saying, well, yeah, 1 over sine squared is cosecant squared. But I was like, do we know for sure that the squared comes along for the ride? And this is why the squared does come along. What about letter G? Very good. M is on a roll. Negative tangent over secant. Okay, so negative tangent turns to negative sine over cosine over 1 over cosine. Now what? Yep. Very good. You guys remember how to divide? I get negative sine of theta. Try H on your own. Go. Oh, try I as well. H and I. Okay, the first one, you want to set it up like this, and then you're going to multiply by sine over cosine. And you notice you get 1 over cosine, which is secant. And then letter I, what do you get in the numerator? Sine over cosine. What do you have in the denominator? Sine over cosine. So sine over cosine divided by sine over cosine is going to give you 1. Emma, I heard the Q word. Did you have a quit? Or are you okay with this? Okay, you're okay with this. Yes, Rachel, I see your hand. Awesome. I have that impact. That takes a lot of work as a teacher. How do we answer questions before they're asked? If you notice, that was just executed. Shoot. thought I did good. Which one? This one? H? Did you have 1 over sine? Okay, so the cosecant you want to write is 1 over sine right away. Cosecant per our information right here is 1 over sine. Better? Okay. Let's check the next one. Got a little bit more work to do yet. We're going to be running up against the clock here. How about letter J? Sine theta over cosine theta over cosine over 1 times 1 over sine. Yeah. Is it the same thing in the top as you have in the bottom? No, it's not, is it? So I multiply by the reciprocal. I multiply by sine over cosine. Does anything cancel? No. You get sine squared over cosine squared, which is tangent squared. You guys are geniuses. Best ever. Try letter K on your own. Go. Go to cosine theta. Sorry. Ooh, wow. You guys are doing well. We're still on level 1 problems. So there's level 1, 2, 3, and 4. We're still in the level 1 realm. So we're going to see level 2 here in a second. But the last one, letter L, this is tangent of x. What happens to cosine of negative x? Cosine of positive x, good. And what happens to tangent of negative x? The tangent is negative, so it's minus tangent of x. Okay, here we go. Letter M, what do we do? Exactly. Everybody wants to distribute right away, but it's the wrong thing to do. This is a level 2 problem. Level 2. It causes you to recognize something, folks. You got to recognize something. There's something else we need to recognize. What is the capital of the United States of America? Washington, D.C. And sine squared plus cosine squared is 1. Hey, let's watch and see what happens with that. Look at your sheet that we gave you guys, okay? Look. Super cool. Look, sine squared plus cosine squared is 1. Watch what happens if I subtract a cosine squared of x from both sides. I get a new formula. I get sine squared of x is equal to 1 minus cosine squared of x. Look, I even put a lot of those formulas over here. Sine squared is 1 minus cosine squared. It comes from this. Cosine squared is 1 minus sine squared. It comes from this. So therefore, you could take your very first piece that you have here, and you can substitute something in. Instead of 1 minus cosine squared, what do I write? Sine squared of theta times cosecant of theta. Anytime you get a squared and a 1, a lot of times there's something you can substitute. So that means I've got sine squared of theta over 1 times 1 over sine of theta. What happens? And you're left with? Awesome. What about letter N? Secant squared. I remember something about a secant squared and a 1. Okay. Yeah. What? This one? 1 minus cosine squared is, that whole piece is sine squared. Let's look at our sheet. Look at what you have here. Secant squared minus 1. Let's look at the sheet. It says, right here, it says secant squared minus 1. That whole piece is tangent squared. See, Rach? That whole piece is tangent squared. So instead of writing secant squared minus 1, I substitute in tangent squared. So I got cosine squared times tangent squared of theta. Can I simplify that? And what do? Cancel them off and get sine squared. Tangent squared is sine squared over cosine squared. How about letter O? What goes in place of secant squared minus 1? We just did it. So I have tangent squared of theta over sine squared of theta. So now I do sine squared of theta over cosine squared of theta all over sine squared of theta over 1 times by the reciprocal. Oh, you guys are smart. We're not going to do letter Q, but we are going to do P and R. See how you can handle this. What's different about P and R? Now you got two tangents. Here's what some people love to do. They take tangent minus tangent is 0 times sine is 0. Done! Woo! What's up? Can't do that. Totally illegal. So I want to rewrite this. Instead of a tangent squared, I write x squared minus x squared times y squared. If you saw that expression and I asked you to factor that expression, could you factor this? What would you take out? Take out an x squared, you'd be left with 1 minus y squared. 1 minus y squared, right? Well, what can we factor out of this? A tangent squared, right? When you factor out the tangent squared, what are you left with? Oh, so sometimes we have to factor something out. Do we? Ashley, thank you. 1 minus sine squared is cosine squared. Hey, does that simplify? So we've got sine squared of theta over cosine squared of theta times cosine squared of theta over 1. Okay, we'll give you one more. Letter R. What do we factor out? A cosine squared of theta. What are you left with? Plus tangent squared. Because it says plus right here. Well, that was not a dumb question. No questions are dumb. Very good. So I have cosine squared of theta times secant squared of theta. Hey, what's the relationship between cosine and secant? They're reciprocals. What happens when we multiply two reciprocals? Not all the answers are sine. Yeah. I've got a worksheet for you. Right?